Hello there, everybody. This video is serving as a little bit of review for our quiz on section 7.1 to 7.3. So, number one, we're just going to rewrite using rational exponents. Now remember, rational exponents is just like it sounds. That means our answer needs to have exponents, but that means they're also going to be fractions. That's what this whole idea of rational exponents means. So we have a formula to do this. So our base is 8. And then we know we need a fraction. So our power is the numerator and our root is the denominator. And that's the same every time. But let's think about this. 8, what is 10 divided by 5? Well, that's 2. So really our simplest answer is 64. But you're not always going to be able to reduce that fraction. Let me show you another example. Here our base is 7, our power is 2, and our root is 3. And I can't reduce 2/3, so my final answer is 7 to the 2/3 power. There are other types of rewriting problems. We could use radical notation. And remember, a radical is an example of that square root sign or the cube root of the fourth root. So we know that our answer needs to have a radical. Remember, the denominator is the root, and the numerator is the power. So our base is 4, our root is 2, so we're taking the square root of 4, and our power is 3. And that's it. So 2b is similar. Our base is 10, but now we're taking the 8th root, and our power here is 5. So that's it for rewriting. We're just going from rational exponents to radical notation, or from radical notation to radical exponents. Just make sure you read carefully to know what your answer should look like. So number 3, solve and give exact answers. That means I don't want a decimal. So we're going to keep a radical in our answer since it says to keep it exact. So we've had lots of issues with this this whole year, so we have to be sure we get our term with our exponent by itself. So that means I need to divide both sides by -4 first, because that goes away. So then I have x minus 3 to the 4th power equals 60. And this next step is very important, right? We have a minus here. So I can't do anything with this exponent in terms of the x and the 3. We're not going to write this out, x minus 3 times x minus 3 times x minus 3. Right? That is much longer than what we need to do. Anytime you're in this situation, you should try to get rid of that exponent. In this case, we have an exponent of 4, so we need to take the 4th root of both sides. So that gives me x minus 3 on this side. I need to reduce my radical. So 60 is, I don't know, say 20 times 3. 20 would be 10 times 2. And 10 is 5 times 2. Now, do we see any 4 of a kind? I don't. I see 2 2's, but since we're taking the 4th root, we need 4 of a kind to simplify that. So I'm going to leave that as plus or minus the square root of 60. Remember, when you take an even root, you need plus or minus. So the only other thing we have to do is get x by itself. So I'm going to add 3 to both sides. So x equals 3 plus or minus the square root of 60. So most problems where you're solving and giving exact answers are very similar. You want to get the term with that exponent all by itself so you can get rid of it. It's just like when we solved with quadratics. Alrighty. Let's look at number 4. Number 4, I want to simplify and leave answers in radical form. That means we want a radical in our answer. But if you remember from class, the first thing we want to do is change all of our radicals to fractional exponents because it makes it easier. So the 4th root of x to the 3rd is x to the 3rd, x, and then our power is 3, and our root is 4. And then we have x as our base, our power is 5, and our root is 4, and that is to the negative 2 power. Now there's a few things we could do here. Since we have the same base, I recommend combining what's inside these parentheses. And remember, when you multiply things with the same base, you add the exponents. And in this case, it's nice and easy because we already have a common denominator of 4. So 3/4 plus 5/4 is 8/4, and that's to the negative 2 power. I'm going to bring up my work over here. So 8 divided by 4 is 2, and that's still to the negative 2 power. And then if you recall our exponent rules, anytime you take a power to another power, you need to multiply the powers. So x to the negative 4 power. Then the last step will be to get rid of that negative exponent. Remember, we don't leave negative exponents in our answer, so in this case we need to move that x to the negative 4 down to the denominator. And then that is our final answer. Again, there's different ways we could do this. We could have brought this negative 2 to each of our terms and then done some combining. So if you want to try this problem on your own and your steps look a little different, that's okay, as long as you get 1 over x to the 4th as your final answer. In a problem like number 5, they're telling us to perform the indicated operation. In these problems, we're really trying to combine like terms. So we need to try to simplify as much as we can until we have like terms that we are able to combine. So remember, if there's no number in front of your radical, we're taking the square root. So in this case, we're looking for 2 of a kind. So 4 is 2 times 2. And I know x to the 5th is x to the 4th times x. And I can also break down x to the 4th as x squared times x squared. So I'm looking for 2 of a kind. So here I have 2 2's and 2 x squareds. So that means I can take out 1 2 and 1 x squared, and I still have that x underneath the radical. So that's the first term. Let's move to the second term. I know x to the 3rd is x squared times x, and that's what I'm looking for, 2 of a kind. Right? You could say that's x times x and circle it there, however you want to read it. So that means I could take out 1x and bring it to the front. I already have an x there, so now I have 2 in front, so x squared, and I'm still left with 1x underneath the radical. So how do you know if they're like terms? Well, let's look at the radicals. We both have square root of x. So since those are the same, that means these are like terms. So I can just do 2x squared minus 1x squared to give me 1x squared, and my variable, or my like term, is square root of x. Again, you don't need to write that 1 in front, but you can. Sometimes it helps us to think through it if we write everything down. Moving on. Number 6. We're going to let f of x equal 3x and g of x equals x to the 1/4. We're going to find the following and state the domain. So in this case, we need to do f of x times g of x. So f of x is 3x, and g of x is x to the 1/4. All right. Well, remember, if there's no exponent, it's a 1 there. And if we multiply 2 terms with the same base, we can add the exponents. So we still have a 3 in front. And then, remember, if it's 1, that's really like x to the 4/4 times x to the 1/4. So 4/4 plus 1/4 is x to the 5/4. So we got to think about this for a second. So we still have a 3 in front, and then we're taking the 4th root of x, and that is to the 5th power. But what I'm mostly concerned about is this 4th root of x. We can either look at the two functions separately, or just look at the answer. Sometimes it's easier to look at them separately. So f of x is 3x, which means the domain is all real numbers. Because we can plug in any x here, and that'll work just fine. Remember, g of x, x to the 1/4, is like taking the 4th root of x, And we know we can't take an even root of a negative number. So for g, x must be greater than or equal to 0. And remember, once we multiply them, our domains are both of those, right? They both count. And we see that by looking at our answer, right? We have the fourth root of x. So our domain is all real numbers except x has to be greater than 0. And that would be our answer. So if we look at part B, we have f of x divided by g of x, which means 3x divided by x to the 1/4. Remember, if there's no exponent, there's a 1 there. And since we're dividing terms with the same base, we can subtract our exponents. And instead of a 1, I'm just going to write 4/4 right away. So f of x divided by g of x is 3x to the 3/4, because 4/4 minus 1/4 is 3/4. And when we talk about the domain, we do need to look at these separately. Remember, we knew that f of x's domain is all real numbers. And we know that g of x has to be x greater than or equal to 0. But what if g of x equals 0, or x equals 0? Then we have a denominator of 0. So we don't want to write the line underneath a greater than sign this time. We want it to be x greater than 0, because we can't divide by 0. So our domain here is all real numbers and x bigger than 0. So all real numbers for which x is greater than 0. So 1, 2, 3, 4, all the way up to infinity. Right here are the last few problems, and I'm going to try to get through them in the next 3 minutes. And if not, we can make a part 2 video to help us out. So let f of x equal 3x to the negative 1 power. And g of x equals 2x minus 1. So I need to find f of g of x. So first I want to find the domain of each of these. So if we look at f of x, 3x to the negative 1 power. If I get rid of that exponent, or I want to make it positive, I need to move that x to the negative 1 to the denominator. So this tells us x can't equal 0, right? Because we can never divide by 0. And g of x is 2x minus 1. Here, our domain is all real numbers. So first, let's find f of g of x. So g of x is 2x minus 1. So we have 3 over 2x minus 1, right? Since f of x is 3 over x. Our denominator can equal 0, so that means 2x minus 1 does not equal 0. Add 1 to both sides, 2x cannot equal 1, so x can't equal 1/2. So f of g of x is our answer that we just got, and our domain is all real numbers except for x cannot equal 1/2. And that would be our answer for part A. And I'm just going to draw a line here so we can still do part B. So g of f of x. Now this is just a little bit backwards. So g f of x is 3 over x. So we have 2 times 3 over x minus 1, which is 6 over x minus 1. And if we look at our final answer, we know x cannot equal 0 because right here our denominator cannot equal 0. So we have all real numbers except x cannot equal 0. And then our last problem, which I'm going to do very quickly, f of x. Well, f of x is 3 over x. So when I plug in 3 over x to 3 over x, I have 3 over 3 over x. Now, remember when we divide by a fraction, we're really multiplying by the reciprocal. So we could say 3 times x over 3, which equals x, right? I just flipped that denominator. So what this means is, all real numbers, since my answer is x, we can plug in anything to that function. So I hope this helps. And if you watch this and still have questions, please let me know in class.